Okay, this is Lesson 7 Markup and Markdown Problems. This is actually in your workbooks today. So looking at example 1, it's about a video game markup. Here's our story problem. The Game Schooler Superstore buys the latest video game at a wholesale price of $30. The markup rate at Game Schooler Superstore is 40%. You use your allowance to purchase the game at the store. How much will you pay, not including tax? So most stores, they get something in for what they call wholesale price, and then they mark it up by a certain percentage. So that way they can make money, obviously. They can't sell it for the price that they bought it for. They don't make any money. So A tells us that we need to write an equation to find the price of the game at Game Schooler Superstore. Okay, so instead of doing the proportion, this one wants us to write an equation. So like I had found before, we know that it is marked up by 40%. So yesterday we did a lot of subtracting from the 100%. Well, it starts at 100%, and then we mark it up 40%. So instead of minusing 40%, since it's a markup, we're adding 40% to that 100. And then we're going to times that by $30. Okay. And then to simplify here, 40 plus, or 100 plus 40% is 140%. 40% times the 30. And I can write 30.00, but it's the same as 30. And then I'll change this to a decimal because I can't multiply percent times a whole number. So change it to decimal, move it back 2 places, or divide by 100, which would be 1.4 times our $30. All right, so there's our equation. B says solve the equation from part A. So now that I have this, all I need to do is take my 1.4, which is the markup, the 100% plus the 40%, times 30. So 1.4 times 30, which would be $42. So the store originally gets the video game for $30. They mark it up 40% to $42, and that's what they sell it to you as. What was the total markup of the video game? Well, it sold for $42. And how much did they pay for it? $30. So to figure out how many dollars they marked it up, I have to subtract those two. 42 minus 30 would be $12. So the total markup, the amount of money that they had to mark that game up, was $12. You and a friend are discussing markup rate. He says that an easier way to find the total markup is by multiplying the wholesale price by 40%. So this is the markup rate, $12. 42 is what they're selling it for now. $12 is how much they marked it up, the markup rate. So he says that to find this $12, it would just be easier to multiply your $30, by 40%, which is 0.40. Do you agree with him? Well, let's check. Let's do 30 times 40%, or 0.4. $12. So that does equal 12. So yeah, we do agree with him. This is an easier way to find the markup rate. not the amount that they're selling it for now, that $42, but the markup rate. Okay, example 2. A $300 mountain bike is discounted by 30% and then discounted an additional 10% for shoppers who arrive before 5 a.m. Find the sales price of the bicycle. So we have two different discounts here. First, we start with the 30% discount. So equation, we had 100 and it's a discount. So unlike before where it was a markup and we had to add 40%, we need to subtract 30%. And then times that by the $300, the price, the original price of the bike. So 100 minus 30% is 70%. Times 300. And 70%, we'll move the decimal back 2 places, is 0.7 times 300. And let's do that real quick. So 0.7 times 300 is 210. So now it's at $210. But that wasn't my only discount. It's at $210. And then it's an additional 10% off if you come before 5 a.m. So now I have to take my 100 minus my 10% discount, which is 90% or 0.90 times 210. And I'll times that by 0.90 or 9, and it's $189. So it was already marked down to $210. Oops. And then if you show up before 5 a.m., you get another 10% discount, and the final price of that mountain bike is $189. So that's a pretty good deal with both of those discounts added on top of each other. B says, in all, how much has the bicycle been discounted in dollars? So what was the original? Well, it was originally 300 and now it's 189. So if I want to figure out how much money it went down by, I'm going to subtract these two to figure out the discount in dollars. Borrow all the way across. This becomes a 2, 9, 10. And 10 minus 9 is 1. 9 minus 8 is 1. 2 minus 1 is 1. So $111. That's a pretty good chunk of change off of $300. After both discounts are taken, what was the total percent discount? Okay, well, a lot of people would like to say, well, 30% and another 10. Well, that's 40%, right? And that's not the case. The reason why stores do 30 and then an additional 10 instead of just saying 40% is because it's actually cheaper or more profitable for them to do a 30% and then a 10%. And we'll see why here in a second. Okay, so if I just put those two together and made 40% discount, that would be 100 minus 40% times the $300, that original price. Well, this would be 100 minus 40 is 60% or 0.60 times 300. And let's see if that is actually the same as that 189, which we got before. So if I did 0.6 times 300, that's actually $189, or $180, excuse me. So, and the way we found it, we did the 30% off, then the 10%, which is what they're going to do when they actually calculate this at the register. And that gives you 189. So you'll notice they don't want to just give you the straight out 40% off, because that would cost them more money than if they tell you, oh, you're getting 30% off and then another 10%. So the way that we show this, the actual percent of discount, is we take the amount of sale, the price that it is on sale, and we don't know the percent, so we'll put a P for the percent. We're trying to figure out what percent this actually is, times the original price of the mountain bike. And then I want to figure out what P the percentage is, so I'm just going to divide by 300 to both sides. Divide by 300. And then I'll take 189 divided by 300. Which gives me 63.63. And I'm going to take the original percentage minus the 63%. So 100 minus 63. That gives me 37, which is the actual percent that's off. So when they tell you at the store, you're getting 30% plus an additional 10%, that's not actually 40% off. That's going to be somewhere in between 30 and 40% off. And in this case, it's 37%. Okay, D says, instead of purchasing the bike for $300, how much would you save if you bought it before 5 a.m.? Well, we've already kind of done the math for this. If we bought it before 5 a.m., we get the 30% plus the additional 10%. And the question is, how much would you save if you bought it? So the price of it with those discounts is $189, and we already figured out how much we'd save. We did that subtraction here. So we're going to end up saving $111. Excuse me. If we buy it before 5 a.m. All right, here, exercise 1 is another one of those double discounted items. It says Sasha went shopping and decided to purchase a set of bracelets for 25% off the regular price. If Sasha buys the bracelets today, she will save an additional 5%. Find the sales price of this set of bracelets with both discounts. And here is our bracelet, cost $44. Well, my first discount is 25% off, so 100 minus, remember 100 is what we start with, 100 is our original percent minus the 25% is 75%, or 0.75 times that $44 for the bracelets. So let's do that. We have 0.75 times $44. So now the bracelets are at $33. $33. Okay, and then if she purchases them today, she gets an additional 5%. So we take our 100, additional 5% discount, so I'm minus the 5%, leaves 95%. I'm going to take the price after the 25% discount times the decimal for this discount, which is 0.95. So 33 times 0.95 would be 31.35. Oops, equals $31.35. Whoa, that was a weird 3. Okay, let's double check and see what it's asking. How much money will she save? Well, this is the price that she's going to pay, but that doesn't tell me how much she actually saved. So I have to do one more step here. I have to take my $44 minus that 31.35, the new price, and subtract to figure out how much she saves. So $44 minus $31.35 is $12.65. So that's not a bad amount to save on bracelets. $12.65 is the amount that she's going to save. Okay, let's look at example 2. A golf store purchases a set of clubs at a wholesale price of $250. Mr. Edmund learned the clubs are marked up 200%. Wow. Is it possible to have a percent increase greater than 100? What is the retail price of the club? Yeah, basically the stores can mark it up as high as they want. They can even go up to 500% up markup. That's kind of up to them. Although if they go too high, nobody's going to buy that product, but they can mark it up as much as they want. So here it's a markup. So instead of subtracting our percent, we're going to add it. So I'm starting with that 100% again. I'm going to add the 200% markup. Oof, that's a big markup, which is 300%. And then I'm going to take that times that $250, which is what they bought the clubs for before they're trying to sell them to you. And I need to change this percent to a decimal. So again, move it over to the left 2 places. So this is just a whole 3 times 250. $250. So 2 times 250 is 500, plus another 250 is $750. Ooh. I don't know what clubs cost, but that seems like a lot to me. So the retail price is $750. And is it possible to have a percent increase greater than 100? Yes. They can have 400, 500% increase. That's 200. That's up to them. All right. And 3, what is a percent increase? What is the percent increase of the set of clubs from $250 to $750? Excuse me. Is the percent increase of a set of clubs from $250 to $750 the same as the markup rate of 200%, and explain? Okay, so it's asking, is the percent increase of this the same as the markup rate of 200? Well, we did percent increase and decrease the other day, so remember that's the original 250 minus the new 750 divided by the original 250. All right, so 250 minus 750 is a negative 500, which we just do the absolute value, so 500 divided by 250, which is 2. And to change this decimal to a percent, we have to move it over 2 places, and that makes 200%. Oops. So the question is Is the percent increase 200% the same as the markup rate of 200%? Yes, they are. The markup rate of 200% and the percent increase are the same thing. Okay, example 3, working backward. So here's one where we have to work backward. We are trying to find the original price instead of the sale price. So a car that is normally sells for $20,000 is on sale for $16,000. The sales tax is 7.5%. What percent of the original price of the car is the final price? So we know we're going to use this formula, this quantity. I might type this out for you. Quantity, excuse me, equals our percent times our whole. Okay, so our quantity and our whole are the numbers that we know here. We're not going to worry about the sales tax yet because we're just trying to figure out the percentage of the original price that the car was. So our whole is going to be our larger number, that 20,000. Times our percent, which I'm just going to put M here for now, equals our quantity, which is 16,000. Okay, and to solve for M, to figure out our percent, I have to divide. Since I'm multiplying, inverse operation is to divide by 20,000. And divide this side by 20,000. Okay, so let's do that real quick. We have 16,000 divided by 20,000 equals 0.8. 8. And to change that to a percent, I move it 2 places to the right, which would be 80%. And let's check to see if that makes sense. What percent of the original price is the final, the 16,000? So the original is 20, final is 16, and that looks, well, it's definitely over half, which would be 10,000. So 80% looks correct. B, find the discount rate. So our discount rate, if we know this is the percent of the original, we have our 100, which is our original, minus 80 equals 20%. That's our discount rate. Doesn't say discount amount, it says discount rate. If it was the discount amount, it would be 20,000 minus 16,000, which would be 4,000. But instead, this says the rate. Okay. It says C, by law, sales tax has to be applied to the discount price. However, would it be better for the consumer if 7.5% sales tax was calculated before the 20% was applied? Why or why not? Well, let's see. So if we had 20,000, that was the original. And they're saying, would it be better if this 7.5% sales tax was calculated before the 20% discount was applied? So let's find this and our 7.5% sales tax. Well, sales tax we know is an amount that's added on. So we have 100% plus 7.5%, which is 107.5%. And I have to change that to a decimal, so move it over 2 places. So this would be 20,000 times 1.075. So let's do that. 20,000 times 1.075. That's 21,500. So 21,500. Okay, so that's with the sales tax, and now we need to apply the discount. So now we have to times that by our discount. Discount would be subtracting, so 100% minus 20% is 80%, which we can write as 0.8. So times 0.8 is 17. Oh, I missed it. What was it? $17,200. So that's with the discount and the sales tax. But we did the sales tax first, calculated that and added that on, and then took off the 20% discount. Okay, so that's the first way. And the other way said by law, the sales tax has to be applied to the discount. So let's do our discount first. So I'd have to do 20,000. Our discount was 20%. So 100 minus 20% is 80%. And we can write that as 0.80. So let's do 20,000 times 0.8. Okay, that gives me 16,000. And then let's put on that sales tax, then times it by the sales tax, which we found out to be the decimal, to be 1.075. Which gives us that same 17,200. It's getting sloppy tonight. Sorry about that. So, would it be better for the consumer? No. It's the same amount either way. We can multiply it by whichever first because of the commutative property of multiplication. Okay, D says write an equation applying the commutative property to support your answer from part C. So we could do this 20,000 times the 1.075 and then times that by the 80%. Which is the same thing as 20,000 times the 0.8 first, and then times the sales tax of 1.075. So those are equal. It doesn't matter which order I multiply these numbers in. I could do sales tax and then the discount, or discount then sales tax. Either way, it's all the same. Okay, so we have some other exercises, but I'm going to stop there and we'll work through some more problems tomorrow in class before you work on your problem set.